Hello everyone. Today we're going to be covering the A-star algorithm, which is in the AI section of the A-level computer science syllabus. So let us see, what is the purpose of an A-star algorithm, or generally any algorithm with pathfinding? So the purpose of the A-star algorithm is to find the most optimal and cost-effective route between two nodes based on distance, cost, or time. So if you imagine I have one person here, I can take multiple routes to multiple places, right? So if I want to go from this point to, so let's say here, the other end, we would have to go through many different places. And the purpose of the A star is to find the most shortest or the most effective way to get there. So this is used in many tools such as for locating good places, such as Google Maps. You're gonna find the shortest path available. And A star consists of two different things. There is something known as the heuristic value, which you also have to consider, and just the cost. So the heuristic value, which is labeled as h, and this is seen above each node. So over here, the heuristic value is 1, 5, 11, 8, 8. And what this represents is this is an estimation of how far this node is from the end node. So how long the node thinks or predicts it will take, or how much it will cost to get there. So if the beginning has a heuristic value of 12, this means that the whatever it was, it thinks it will take 12 units of whatever distance, cost, money, time to get to the end. Similarly, at D, it thinks it will take 11 units. At G, it will take 5 units. So let us see how we're supposed to solve the heuristic and A star algorithm in terms of a question. So we can see we need to calculate the shortest path from beginning to the end node using the A star algorithm. I'm going to show off our working like usual. So how this works is initially we want to travel to every node possible. So if I'm at begin, I want to travel to every node that is possible. So if I'm at begin, I can go to many places, right? So let's just write it down. So if I begin, I can go to A like this. I can go B, C, or D. So B, C, or D. Now, to calculate the actual cost, that's G, that is the values on the lines. To get to B, the cost is 6. And the heuristic value, you think it'll take is 7. So we write 7 here. And then we have total, which is just a sum, which will be 13. Similarly for C, the actual value is 5. But the heuristic value is 7, so this is 12. Then to D, it's 4 here, and then 11, so 15. So I am at begin, and I can go 4 different paths with each of the costs being the following of these. Right, so which way would I go to? I would obviously go to the shortest way possible. So I would go to C. Right, so we can describe our path as being begin, then going to C. Now, awesome. Now, if we remove all of this, we can see we are at point C. Now, how many different places can I go from point C? You want to make sure whatever node you are at, you need to traverse every path that a node is connected to, other than where it came from. So, in our case, we can only go to one different place, which is G. So, if you write G, start node is C, and we want to get to G. The actual value is 2, the cost is 5. So when doing this, what we will have to do is so what we will have to do is we'll need to write total cost. So the total cost of getting from C to G is 5 plus 2, since I'm going through the beginning node, right? So I can write 5 plus 2, which is fine, that will be 7. And the heuristic value will be 5. So it'll be 7 plus 5, which will be equal to 12 here. Now, I'm a G. What are the different places I can go? I can either go to D, I can go directly to the end, or I can go directly to F. So again, we need to do the table. So we get G, G, G. I can go to D, end, or F. Awesome. So if I go to D, the cost is 5 plus 2 plus 6, 5 plus 2 plus 6, 7, 13, and then it goes to 11, so we know that is definitely our answer. I can go directly to the end, so that cost will be 7, right? Because we're going there. And what will be the heuristic? You can see there's no heuristic value because we're at the end. There is no more prediction of how long it will take because I'm there. So we can set this to 0. So this will not be 7. This would be 5 plus 2 plus 7. This will be equal to 14. Now, where else can I go? F. Alright. I can go 5 plus 2 plus 4. 5 plus 2 plus 4. So, and we have a heuristic cost of 1. So hey, we can see here, this will be equal to 12. Right? So we can choose of these, we can choose to go to G. And then from G, what are the different places I could go? From G, is this going straight to the end? We can go straight to the end here, or we can go E, but we can just leave that. So F to E, F to end. So F to E would be 5 plus 2 plus 4 plus 7. Correct? Yeah, that would be 11, 18, and then 8, so we know that's 26. And to go to the end, it would be 5 plus 2 plus 4 plus 1. The heuristic value would be 0, and hence you can calculate the total as 12. And then we would go to F, and then we would go to the end. Awesome. So this is how the A-star algorithm works. And if we look at the mark scheme over here, we can see, let's just go through all the different marks we got. So we definitely got the mark for the correct path. We need to go 1 mark each for the correct, so we're going to B, C, and D. And then 1 mark for each correct calculation from G to C. No G from C. We go from, this is the node right here. Got that mark. Node F and node end. Going to node F and node end for G over here. Yep, awesome. That would be correct. And then we can go from node end from F. So that would be the final one, and that will lead to this. Hence we can say that, we got full marks over here, and we can easily snag that 5 out of 5. So this is a decently common question. You can either get this, or you can get the other one, the Dijkstra's algorithm, and that hasn't been tested too many times in the new syllabus yet, so this would definitely be a hot topic that can come. So yeah, best of luck and good luck with your preparation.